Use the recursive definition given to determine the second and third terms of the following sequence. Okay, so what we've got here is a recursive rule. We know it's recursive because it's got the tn plus 1 and the tn here, and it's basically saying to us that a particular term is equal to 0.5 times the previous term, take 8, and the first term t1 is equal to 20. Okay, in this case we want to get the second and third terms. We've already got the first term. So second term here is going to be t2 is equal to 0.5 times first term, which is t1, take away 8. And we know t1 is equal to 20, so we just sub it in where the t1 is there. And we get t2 is equal to 0.5 times 20, take away 8. So half of 20 is 10, 10 take 8 equals 2. There's your answer there. T3, very similar. This time we're saying T3 is equal to 0.5 times T2. So this particular term is equal to 0.5 times the previous term. So T2 we've worked out is 2 already. So this 2 value here, pop it in there and still take away 8. Just work that out. So 0.5 times 2, half of 2 is 1. So we've got 1 take 8, and that'll give an answer there of -7. So maybe writing your answer out over here. So it's nice and clear. T2 equals 2. T3 equals -7. Okay, so it goes on to the second part of the question here. Consider the sequence. So a completely different question. Consider the sequence 5, net 1, -3, -7. You can see with this sequence that we're getting 4 subtracted each time. So it's got a common difference here of -4, which means it's an arithmetic sequence. And it says deduce the rule for the nth term. Now, really important here, you need to know what you're doing here. The rule for the nth term is a general rule, so you can skip to any term, as opposed to our rule over here, which is a recursive rule. To use this rule, you need to know the previous term before you can find the next term. So a little bit different here. Deducing the general rule then for the nth term. So first of all, you've got to know that you're looking for the general rule. We can use this little sort of idea for an arithmetic sequence. It's Tn is equal to A plus n take 1 times D. So any term number is going to be equal to A. Now A is the first term. N is the term number itself, and D is the common difference, which we know is -4. Okay, so we can just sub in the values we know here, and we know the A value, the first term. The first term is in fact 5, so we just put the 5 in there. And then we've got plus n take 1. Now, the common difference is -4. You've got to be careful here. We want to times by D. So you can't just, if you just put take 4, it looks like you're subtracting 4 from the whole thing. We're actually multiplying by -4. And in this case, it's probably easier to put that -4 in front of the bracket as -4 times n take 1, just so it looks a bit better. Now that's an answer there. You've got it. If you wanted to simplify a bit and expand out these brackets, you could. You get Tn is equal to 5 take 4n. Don't forget -4 times -1 when you expand out that bracket gives a +4. And then we can collect our like terms. 5 plus 4 is equal to 9. We get 9 take 4n. Now, this rule here that we're using is for where you've got a T1 as your first value. If you get the case where there's some initial value, there's a T0 value, you'd actually use this rule over here. Tn is equal to A plus ND. And just be aware of that, I guess. Generally speaking, I like to use this one here, which is for any sequences where we've got a first term. If there's an initial value, a T0 value, a lot of finance applications are like that, you can use this rule here. But I guess most important is just making sure that your rule works at the end of the day. So down here, if I want to find T2, it would be 9 take 4 times 2, which is 9 take 8, which gives us our second term of 1. So I'm confident this rule is working because I've substituted into it. Okay, the second part of this question was this little one here where we want to determine the value of n for which Tn is equal to -191. Now you've got a couple of options on this one. We can do a bit of trial and error perhaps. So if you're looking at the term -191, that's going to be a long way down here. Okay, you're going to be going a fair way down to that -191. Now you can see we've got first term, second term, third term, fourth term. So what you could do is you can maybe guess it and just say, look, I'm going to guess that it's the 40th term. So if it was the 40th term, you'd say T40 is equal to 9 take 4 times 40. So I'll just put guess next to that. Oh, yep, there we go, still on the screen. T40 is 9 take 4 times 40. That'd be 9 take 160. You've got to be careful with your negatives here. 9 take 160, we're actually going down below 0. You'll get negative 151. And you can see that's not correct because we want to get down to negative 191. We need the n value to be quite a bit bigger. So then you can take another guess. Maybe you could try T45 is equal to, work that out and see if it comes out to this negative 191. You can see it's a bit of a, can be a bit of a long process unless you get a bit lucky or you're good at picking which value it is. Second method you can use for this one, we can actually start with our rule, Tn is equal to 9 take 4n, and substitute this value of negative 191 where the Tn is here, and then use some algebra. So what we can now do, we're trying to find the n value for when Tn is negative 191. We can just go and solve this equation using a little bit of balancing. Remember, with our algebra, we're trying to get the n by itself, so we might subtract 9 from both sides here. Again, you've got to be super careful with your negatives here. It's negative 191 take 9. Remember, this is calc free. So you're going down further below negative 191. In fact, that'll get down to negative 200. And again, a little tricky one, this one. You see this negative 4n. If you're trying to get rid of that negative 4, students will think, oh, I'm going to add 4 to both sides. But in actual fact, this is negative 4 times n. So we need to divide both sides by negative 4, like so. So there we'll get n is equal to, here we've got a negative number divided by a negative, which is a positive, and we've got 200 divided by 4. Well, if I split 200 up into 4 even parts, that's 50. So therefore, the value of n for which Tn is equal to negative 191 is n is equal to 50. There's our solution there. And of course, you can check that by subbing it back in to your equation. If you go 9, take away 4 times 50, you'll get to that negative 191.